That's exciting. And what are some of the most promising advancements you have seen in additive manufacturing for electrical machines, and how they may impact the industry, playing a major role in the energy transition?
Our team was established in 2014, and at that time it was very difficult to find suppliers capable of printing copper samples, and material properties were far from ideal. So it is very difficult to match the electrical conductivity of conventionally manufactured parts. Now it's improved already, but there is still room for improvement. Another challenge was the feature sizes which we could print, because the accuracy of the print of your part will depend on the particle size of your powder which you use, on precision of the power source, and the thickness of the layer which you print. And now we have access to much finer powders, lasers with much smaller spot sizes, and we can print much thinner layers. All these advancements result in better dimensions of your part and finer surface finish. Also, over the past decade, we've seen a better adoption of this technique among industries, and now it's taken more seriously, not just as a prototyping method, but as a viable production solution. Also, the cost dropped down for the past years, and for example, the parts which we typically print nowadays, they cost 3 times cheaper than they did a few years ago, which is very encouraging for us. And finally, there are some more exciting additive manufacturing techniques on horizon, and with them we'll be able to print even more complex shapes at even lower cost.
You just mentioned some, but I don't know if you want to add something on that. What are the biggest challenges that researchers face in integrating additive manufacturing into electrical machines?
I think that the biggest challenge at the moment is there are 2 entities which exist. So one is designing and manufacturing electrical machines, and one is new emerging additive manufacturing companies which offer a new service of printing parts. And there is no strong link between them. And this is where a research group like ours come in, and we act as a bridge between them. And with our in-depth knowledge of electrical machines and understanding what additive manufacturing can bring to improve these machines, we aim to improve the efficiency of the machines and create products that are greater than the sum of their parts. But also there are some other challenges which are related to additive manufacturing technique, and some of them I already mentioned today. So achieving high electrical conductivity is still a challenge for copper and aluminum parts, because additive manufacturing is known for especially powder-based techniques. They lead to contaminations and porosity, which reduces the electrical conductivity of our parts. And also there is lack of standards to evaluate the quality of our parts. And another issue is surface finish, which can be rough, and that increases losses. And also, when we print our additive manufactured winding, we need to apply insulation. And before that, we need to post-process and reduce all the sharp edges and rough surface finishes. And that's why our team is also working on development of high-performance insulation systems for these complex geometries, which we build with additive manufacturing. And of course, there is cost, which dropped over the past years, but it's still higher than all these conventional mass production methods which are used.
And looking ahead, what key projects are you currently working on that you'd like to highlight and share?
As additive manufacturing becoming a feasible manufacturing solution, we need to start and rethink the traditional design methods which we were using before, if we want to take all the advantages of this additive manufacturing process. For example, topology optimization and multi-material printing, and also we need to think of DFM, design for additive manufacturing steps to take. And one of the areas which we need to think of is to create some flexible design tools to automate and streamline the design process, which will reduce the manual efforts and human errors which are involved in this design process. And this is what I'm currently working on. I'm developing a design tool which will optimize and generate a coil design for electrical machine of interest. And another stream of my work is on establishing standards to benchmark the quality of the parts, to give confidence to industries that every part which they build will match their requirements. And also this will help to accelerate the adoption process for additive manufacturing. So, for example, currently I'm working on developing a standard for measuring electrical conductivity of additive manufactured parts, and also thinking about the standard shape which will be suitable for additive manufacturing production. And another thing is that over the past years we've collected substantial portfolio of successful projects with different companies, redesigning coils and improving the efficiency of different machines. And in the next 12 months we would like to create demonstrate a platform to showcase the benefits of using additive manufacturing for electrical machines and show our end-to-end digital design to digital manufacturing capabilities.
That sounds incredible, innovative. Speaking of collaboration and innovation, events like CWIEME are platforms where industry leaders, researchers, and innovators come together. How important are these platforms for an organization like the University of Bristol?
So in order for us to generate some new ideas for technologies or designs, we need to have a good understanding of the manufacturing processes which are currently adopted. And that's why events like CWIEME are very important for us. And that's why we've been attending it for the past 10 years, because it gives us a unique opportunity to meet all the manufacturers, material suppliers, and communicate with them and to understand what's going on at the moment. And then we can think how we can improve that. Also, we can collect some samples and try them with our new ideas. And beyond gathering knowledge, events like CWIEME help us to showcase our capabilities as a team and show the impact of our research. So at these events we can meet with industry leaders and other research groups to facilitate new collaboration and innovation. And this year we are excited to present for the first time at CWIEME Berlin, and we look forward to showing our work and speak with community.
Yeah, that sounds fantastic. And at CWIEME as well, we have launched dedicated programs to bridge the talent gap, that is the future engineers, and to raise awareness and support the industry efforts to create more diverse workplace with women in engineering. What advice would you give to students and young professionals interested in pursuing a career in the sector?
I think my advice will be very simple. Follow your heart, follow your passion, and show your interest. And then your enthusiasm will be recognized and those around you will support it. But you need to remember that if you don't express your ideas and goals, people cannot support you. And currently we are tackling critical challenges toward a net zero future, and we need talented individuals to join us. And your background and gender doesn't matter, but what truly matters is your passion and expertise.
Yeah, inspiring. Well, and thank you, Anna, for sharing your insights and journey with us today. It's clear that your work is making a significant impact on the future of electrical machines and energy systems. Thank you, everyone, for watching us today, and I'm looking forward to see you all at CWIEME Berlin 2025 from the 3rd to the 5th of June.